Hey guys, in this video we'll be going over the shifts and the rotates, so stick around. Okay, so now let's go over the shifts and rotates and the difference of all of them. So what is a shift? Well, if I were to put some random bytes over here, 1 0 0 1, some random bytes. And what a shift is pretty much you're gonna shift all of this either to the left or going to the left. So if this is your right, it's moving to your left, going this direction. Whoops. And if you're doing a right shift, you're moving from the left to the right. So you're going to the left. And what we're moving when you're doing a shift is a 0. So if I were to shift left, this will become a 0. So this will be a 1. This will be a 0. This will be a 1. This will be a 0. Oops. This will be a 0. This will be a 1. This will be a 1. And this one over here that's left out, this will go to the carry set. This will be the carry flag and the flag or this processor status. So this is what will happen when we use a left shift. And of course, so let me go back all the way back. Oops. Whatever. If we go to do the right shift, the 0 is coming this way. So this will be a 0, 1, 1, 1, 0, 0, 1, 0, and this one, or if it was a 0, whatever the result is gonna be stored in the carry. So if this was 0, that'll be a 0. If there's a 1, it'll be a 1. So let me go back. So that's essentially what a shift is. So, but let's go through the difference that we have with when using assembly, and that is we have a arithmetic shift versus logical. Put yellow or green. So what is the difference? Well, the sample I just showed right now was pretty much a logical shift. So this is moving 0 and we're shifting to the left and to the right. That was a logical. But what is the arithmetic shift? It's pretty much this sign over here. Let me choose a color. Okay, blue. Okay, so this sign, as you remember we went through before, it's the AND flag. So if this is a 1, it's a negative number if you're using unsigned number. If you're using a signed number, this wouldn't matter. So but this is the sign on the arithmetic shift. We use the sign numbers. And why sorry, and why that matters? Well, if you, for example, if you've been using the this is a 4, this is a 7. So if you've been using the decimal system, if you were to shift the decimal system, let's say if you add a 0 over here, so it's pretty much we just this value instead of 47 become 470. However, if you were to shift it this way, to the right, we're dividing. So 4.7. So when you do a shift to the left, you're pretty much multiplying, and if you're doing a shift to the right, you're dividing. But since decimals are base 10, we are either gonna have times 10 or divided by 10. So that's the difference. Well, if you remember in bytes, if this is negative, and if you shift a 0 like a logical over here, it changes the complete numbers that's represent as if it was a sine number. If it was a sine number, oops, sine number. Oh, not bad, not bad. Was a sine number. Instead of this being 0, 1, 1, 1, 0, 0, 1, 0. This is not a negative number, it's to become a completely different number. I'll probably put a number over here to check the difference over here. But if you're to use the arithmetic shift, you would preserve this negative, this 1 over here. So it would preserve it, so it'll become 1, and then the negative, whoops, so many errors. So you preserve this 1, and this, and the 0 would start from the 7th place. So it becomes 0, then it's 1, then it's 1, 1, 1, then it's a 0, 0. Oh, 1, 1, 0, 0, 1, 0. So that's the arithmetic. Because we are preserving this 1, and the shift is going to begin. So let me change the color. So the shift is going to begin from here. So that's the main difference between the arithmetic versus logical. So let me go back all the way. So now we went over shifts. So now let's go over rotate, which is pretty much almost identical. The difference between the shift and rotate, you can rotate left or right, is the carry. So I had an error. So if we, for example, were to rotate left, so going left, what will happen is we're gonna get the whatever the carry set is either 1 or 0, 1 or 0. So let's say, for example, if this is 1, let's say it's a 0. So if the carry is 0, so put a C to represent carry, and let me put this arrow over here because it's way prettier than my arrows. So if the carry flag is set to 0, it means this one is gonna then it's gonna rotate to the left. So it's exactly the same. So 0, 1, 0, 1, 0, 0, 1, 1, and this now is gonna be the new number. The carry is set to 1 because this is 1. And if we're to shift left one more time, well, now let me erase this. Let me increase the size over here and erase this. Now the carry is 1. So let's put here 1. Oops, go back 1. So now it's 1. So now this is gonna shift 1. This is gonna be the first one, and this is gonna rotate to this side, and then this side, and then 1, and then 0, and then 0, and then 1. Whoops, actually, my bad. I'm using this one. This is the actual value I have now. So if you rotate left one more time, the 1 will be here, and this will be a 0, this will be a 1, this will be a 0, this will be a 1, this will be a 0, this will be a 0, this will be a 1, and the carry will be 1 again. So that's what a rotate is. If you did the rotate right, it's the exact same thing, but going to the right side. So let me show you guys on the emulator. Okay, so let's go through the example of the shifts and rotate. So first we're gonna begin with load the accumulator with the value, let's say a negative number. So let's E0. And now we're gonna use the ASL. Let me put ASL, I'll put this in capital letters. The A is the arithmetic, shift left. So we're shifting left. That's where the shift is going to. So so that's what it means. So let me show you the binary for E0. So it's 1, 0, so the first one, 0, 0. So that's the binary representation of E0 in hex. So let me put on let me give some space over here. So with a shift left, you're expecting a 0 to come to here. A 0 is going to come through here and push everything else, and this one is going to be gonna set this carry over here. So not only expecting this number to become, so if a 0 comes over here, it's gonna be 0, 0, 1, 1. So expecting this and this C be set to 1. So let's assemble and run this. So this is arithmetic shift left ASL. So let's assemble and let's go debug. Let's step. So the first one, we have our E0 an accumulator since it's a negative number. So now let's do a left shift, and here it is. C0 corresponds to this binary. I checked, and as you see, the carry that was this one is over here. So that's what we've been expecting from our left shift. So now let's do the exact same thing, but let's do the logical shift right. Let me put in capital, logical shift right. So the L for no mnemonic, logical shift right. So there's our mnemonic. So put this over here. So what I'm expecting is the 0 to come through here. So this will be a 0, 1, 1, 1, 0, 0, 0, 0. And there's the extra 0 is gonna be go to the carry, which is not gonna change since you're gonna assemble and run. So we're expecting to have this byte number, which I believe is the same in hex as 011170 in hex. That's what I expect your accumulator to be. So let's assemble. So let's step. So here we have it's a negative number. Now let's step one more time, and here it is 70. And if you remember from previous video, the sign numbers begin at the hex value 80. So so as you see over here, it's not a negative number anymore because it's a logical shift. In contrast with the arithmetic shift where it keeps the sign. So you can see here in demonstration. So now let's go to the rotates. like we shown you. So here, still the same number. So now we're gonna rotate. Let's rotate left. Row the mnemonics. Rotate left. So what are we expecting over here? Let me delete this now. Is since our carry flag over here, we're gonna is 0. It's gonna be 0 since we're beginning the program, and so we're expecting a a 0 to be shifted to the left. So this is a shift left with the carry. So since it's 0, it's gonna be 1 1 0 0 0 0 0 0. You're expecting that one, the extra one over here, to be in their carry. So that's pretty much like if you see it's gonna be C3, so I mean C0. So that's pretty much the same as our arithmetic left shift. So let's do it one more time. So because now we see this one carry over here, so let's do it one more time just for this time. So now, whoops, I'm expecting a 1 to be shifted over here. So this is gonna be a 1 0 0 0. Whoops, 0. So 3 more zeros over here and a 1. 1 0 0 0. Which I'm expecting the hex value of 81 maybe. Let's assemble and run, and here it is, 81. So let's reset. So debug. So we loaded the value. Here's your carry over here, and here's that one that's shifted over here. So that's our rotate left. So now let's go to our rotate right. Rotate right. That's your mnemonic. So since it's gonna be 0, every time when you assemble and run from the beginning, this value is gonna be set. So we expecting, oops, a 0 to come over here, 0. So it's gonna be 0 1 1 1 1 1. Oops, 1 1 1. I'm sorry, all 0. So pretty much like your shift right, or logical shift right. So if you assemble and run, you got 70. It's not a negative number, exact same thing. But let's do one more time just to show you that it's gonna be another 0 over here because the carry is 0. So I'm doing 0 0 1 1 1 0 0 0. So this other 0 is gonna go to our carry. So we're expecting the hex value 38. So let's assemble. So let's go step by step. Loaded, first shift, and here it is, 38 hex. It's perfect. Hey guys, I just noticed that we also went a little bit over only on this shift and rotate subject. So I'm gonna split this video one more time into another one, and we'll go over all the rest of the instructions that I've read in mind. So thanks for watching, and see you in the next video.